Good morning. We are going to be covering lesson 66, solving polynomial equations. And then in parentheses, we're going to be solving either by factoring or synthetic substitution. And so I'm going to do the lesson practice with you on page 473, and I will insert a couple of examples as we go. Now remember, solutions are called zeros, roots, and they are the x-intercepts of the graph. So if you wanted to use a Desmos and you could identify the x-intercepts, meaning where it intercepts the x-axis, that would tell you the solutions. But know that you're going to see words like solutions, zeros, roots, x-intercepts. So they're all interchangeable. So starting on page 473, part A, and remember for all of these we are solving for x. So part A, x to the fourth minus 3x cubed minus 28x squared equals 0. Now I'm going to go over a couple of things, couple of vocabulary. One, degree, and the degree equals the degree of an equation is one, it's your largest exponent, but it's also the max number of roots or zeros that you could have. So in part A, I have a degree of 4, so I could have up to 4 different solutions. So really important because it gives you a guide of when you know you're done. So if I have a 4th degree polynomial, I should be able to identify 4 solutions. So here we go. The first thing I'm going to do, I'm going to factor out the GCF. So these 3 terms have x squared in common. So that would leave me with x squared minus 3x minus 28. Then I'm going to factor this part here. So I've got negative 28 and a negative 3. That would be negative 7 and positive 4. So my factors are x squared, x minus 7, and x plus 4. Now remember, they set this equal to 0. So the zero product property is something we learned in Algebra 1. If this equation equals 0, then I can find my solutions by setting each factor equal to 0. So that's what I'm going to do, set each factor equal to 0. So x squared equals 0, x minus 7 equals 0, x plus 4 equals 0. And then I'm going to solve each one. So if I take the square root here, x equals 0. If I add 7, x equals 7. And if I subtract 4, x equals a negative 4. And so there are my 3 solutions. Now, we could have had up to 4, and so let's talk about this one here. The x squared equals 0. There's technically 2 solutions which are both 0, and so you would say that it has a multiplicity of 2, but for the sake here, they just wanted the solutions. So for part B, it says to solve 18x cubed minus 18x equals 0. So the first thing I'm going to do is identify my GCF. There are 2 terms here, and I notice that both of them have an 18 and both have an x. So when I factor that out, I'm left with x squared minus 1 and then this is equals 0. So we're going to do the same thing here. I'm going to set each of these factors equal to 0. So 18x equals 0, and x squared minus 1 equals 0. So if I divide this one by 18, x equals 0. If I add 1, x squared equals 1, and then I'm going to take this square root, so x equals a plus or minus 1. So I have 3 solutions because my degree is 3. So 3 possible zeros or roots, and we just found all 3, right? 0, 1, and negative 1. Okay. So really important steps that we're going to follow. All right, next one. 2x cubed minus 32x plus 128x equals 0. Okay, so same steps. I'm always looking for a greatest common factor. So I have 3 terms. I noticed the greatest common factor in this one is 2x. So I'm going to divide 2x out of each term. Leaves me with x squared minus 16x plus 64. I guess I didn't need as much of a... Now I'm going to factor this guy. So 64 and negative 16 would give me negative 8 and negative 8 because their product is the positive 64 and their sum is the negative 16. So I'm going to bring down my GCF and then I'm going to write my 2 factors. And this says equals 0. Now remember, to solve, I set my factors equal to 0. Now I notice that I have 2 factors that are identical, so I'm only going to solve one of them. For this one, right, I would divide by 2, and for this one I would add 8. So x equals 0 and 8. But because of these 2 identical factors, and technically positive 8 is a solution twice, but instead of writing it 2 times, you would say x equals 0 and 8 has a multiplicity, and I believe the book asks, of 2, and 0 has a multiplicity of 1. Meaning that there are 2 8s that are a solution. That's what multiplicity of 2, but there's only 1 0. But that I would just circle. X equals 0 and 8, but 8 has a multiplicity of 2. All right, so next one. Part D. X to the 6th plus 12x to the 5th plus 27x to the 4th equals 0. So from here, again, same steps, guys. So what is our greatest common factor? Keep factoring if you can, and then identify your solutions by setting them equal to 0. So my GCF for this one is x to the 4th, right? They have x's in common. They do not have any numbers in common because there is an invisible 1 here. And 1, 12, and 27 don't have anything in common. So I'm going to divide x to the 4th out. So I'm left with x squared plus 12x plus 27 equals 0. I'm going to factor this guy. So 27 and 12. Factors of 27 are 3 and 9, and they would both be positive. So x to the 4th, x plus 3, x plus 9 equals 0. Now hopefully you can start to see some patterns here. Now this original equation has a degree of 6, which means I have 6 zeros. Remember, zeros means solutions. So 4 of them are here, right? X to the 4th, 4, 5, 6. What? Okay, let's write our solutions. If I set x to the 4th equal to 0, I just get 0. I have x equals, if I set this equal to 0, x equals a negative 3. If I set x plus 9 equal to 0, I get x equals negative 9. Now, these only occur once because their degree is 1 and there's not identical factors. So this has a multiplicity of 1. But x to the 4th means that this 0 has a multiplicity of 4. What's most important, though, is that you solved it. X equals 0, negative 3, and 9. Now, I believe the rest involves some more complex solving. And so we're going to do, I'm going to do some examples. I'm going to break off and do some examples where factoring might not work. So solving using synthetic. All right, so I'm going to do an example with you that's not in the book. So x cubed minus 2x squared minus 11x plus 12 equals 0. Now, the reason I'm using synthetic is because I can't factor this by grouping, and I can't factor this using our x tool because I have 4 terms and I can't group them and take out a GCF. 11 and 12 have nothing in common, and these two, they have x squared in common, but it's not going to give me twin factors. So I'm having to use synthetic. So the first thing I'm going to identify is that my degree is 3, so I quite possibly have 3 solutions. That's the first thing I do. Then I identify my possible zeros. Now, possible zeros equal the factors of the constant divided by factors of our leading coefficient. So if I want to go searching for the possible solutions to this polynomial, I'm looking at 2 numbers, the last, which is your constant, and the first, which is your LC, right? Here is my LC, it's an invisible 1, and this here is my constant. So my possible zeros, I like to put PZ, okay, are factors of 12. Factors of 12 are 1 times 12, 2 times 6, and 3 times 4. Look how that put them in numerical order. I also don't know if they're going to be positive or negative. So technically, I could put a positive or negative in front of each one because I'm not sure. Now, when I use synthetic, do you remember what I'm searching for to know if it's a solution or a factor? I'm looking for a remainder of 0 means value is a solution. So I'm going to set up my synthetic using the coefficients up top. Remember 1, negative 2, negative 11, and 12. And I'm going to try the very first number in our possible zero list, which is a positive 1. And I'm going to pray it works. So I'm going to bring down the first number, multiply by the number on the outside, add to come down, multiply by the number on the outside, add to come down, multiply, and I get a remainder of 0. So this means that is a solution. So positive 1 is my first solution, and I know that because I got a remainder of 0. Now I'm going to write my new polynomial. I have 1x squared minus 1x minus 12. Remember, we start 1 degree less than our original. So x cubed, 1 degree less, is x squared. And I can factor him. That's easy. Negative 12, negative 1. Factors of 12 are 2 and 6 and 4 and 3. So that'd be a negative 4 and a positive 3. So if my factors are x minus 4 and x plus 3, and this equals 0, then my solutions are a positive 4 and a negative 3. And I know I'm done because I filled in all 3 spots. So we're going to do that again. I know that was a lot, but you have the book and you have me to help as we go. So let's try let's try part E from our lesson practice. So we are solving x cubed minus 5x squared minus x plus 5 equals 0. Now, I could factor this by grouping, but I want us to practice the method I just showed you. So my possible zeros are factors of the first number divided by, factors of the last number divided by the first. And I skipped that on the last part because this is a 1, and 5 divided by 1 is just 5. So this isn't really going to come into play until that's not a 1. So factors of 5 are 1 and 5. Right? And factors of my LC are just 1, which just leaves me with 1 and 5. My degree is 3, so I've got 3 possible solutions. So we're going to use synthetic, and we're looking for a remainder of 0. I like to try the first number that they give me. So first number on my list is a positive 1. So I'm going to bring down the first number. 1 times 1 is 1. Add to come down. Add to come down. Multiply. Remainder of 0. So this tells me that right there is my first solution. And it's going to go here because I got a remainder of 0. Now I'm going to write my new polynomial. And I'm going to factor it. So my factors are negative 5 and positive 1. Now remember, these are my factors, not my solutions. You have to look at it. Okay, so what would make 0 here? A positive 5. What would produce 0 here? A negative 1. So my solutions are 1, 5, and negative 1. Now, the next one. I am going to do another 2 more examples. So x cubed plus 4x squared minus 5x minus 14 equals 0. All right, so again, I have a degree of 3. So I'm going to write my solutions. And I'm going to list my possible zeros, and I'm looking at the last number. This first number is 1, so I don't need to worry about it. So factors of 14 are 1 times 14 and 2 times 7. And I don't know whether they're positive or negative. I don't know. So again, I always like to try the first number in my list. I'm going to list my coefficients from the polynomial we're solving. So 1, positive 4, negative 5, negative 14. So make sure you have the signs lined up. All right, so if I bring down the 1, 1, 5, 5, 0, 0, oh. Because this is not 0, that positive 1 is not a solution because my remainder is not 0. So then I would cross positive 1 off, and I would try negative 1. Start over. So 1, 4, negative 5, negative 14. Now if you're like, hey, I don't want, wait a minute, are you telling me I've got to try more than one number? Yes, unless you get out your handy dandy Desmos. And I'm going to enter my equation. Y equals x to the cubed plus 4x squared minus 5x minus 14. So I've entered my equation. And so I'm going to look at my x-intercepts. These, and I wish you guys were here, but these two are at decimals, and I don't know. Look, you could just write down negative 4.414. Click on this one, negative 1.586. Click on this one, 2, 0. Well, that's a nice number, 2. That tells you what to start your synthetic with. 2 is going to be the first one that works. Okay, so but I'm going to show you how to find the solutions by hand. So again, if I had tried -1, notice I'm not going to get a remainder of 0. So -1 is also not a solution. So then I would have moved down the line and I would have tried 2. 2 times 1 is 2. This gives me 6, 12, 7, 14, 0. So my first solution is 2 because it's the first number to give me a remainder of 0. So now I've got 1x squared plus 6x plus 7. Now this is not factorable. There is no factor of a positive 7 that will give me positive 6. This doesn't work. Maybe you have Desmos, maybe you don't. If you were taking this class in person, we don't use Desmos on the test. So I did teach you a method recently that I can use that does work, and that's the quadratic formula. So A equals 1, 6, and 7. Now in your Desmos, it'll give you the decimal form. I'm going to go ahead and do the radical form. So x equals a negative b. Sorry, why did I write A for all of these? A, B, C. -6 plus or minus 6 squared minus 4 times A times C all over 2 times 1. So I got -6 plus or minus all over 2. I'm going to simplify what's in here. 36 minus 28 should be the square root of 8. Now, you could do two things. I would take the decimal form, but if I were to simplify the radical, the square root of 8 is 2 root 2 over 2. And then I can reduce these by 2. And so I end up with x equals -3 plus or minus square root of 2. So one of my solutions is -3 plus the square root of 2. One is -3 minus the square root of 2. Now, I will accept if you find these in decimal form. See if they matches my Desmos. -3 plus the square root of 2. Yep, -1.586. And the bottom is -3 minus the square root of 2, which is -4.14. And those are the same solutions we saw on Desmos. So you can do either, but because you guys are at home, I would like to see you guys be able to solve them by hand, and you can confirm it with Desmos. We're only going to do one more. Sorry, let me move all my stuff. And so G, I don't know if I'm going to do H. We'll see. See, this video is already 23 minutes long. I'm not sure if anyone's watching it, but if you are, thank you. It'll only benefit you for when you move on to take trig. All right, so again, notice this section is nice to you. I only have a degree of 3, and so I have 3 solutions. My possible zeros are factors of the last number, which is 18, and 18 does have a lot of factors. 1 goes into it. Now, I'm lazy, so I stop writing plus or minus because that's tiresome. So 2, 3, 6, 9, 18. Those are all the numbers. They're all positive or negative, but I like to use shorthand. So this one is a pain in the butt to use. So I'm going to use Desmos because guess what? If I use synthetic, I'm going to be here for a long time. So I'm going to go back into my last equation, and I'm just going to change it so that it matches this one. So in Desmos, y equals x cubed plus 2x squared minus 45x minus 18. And so I'm going to zoom out, but I notice I'm looking for where it crosses the x-intercept, and it crosses here at 6. So that's where I'm going to start. So I'm using Desmos to confirm that x equals 0 is an x-intercept, and so that's actually where I'm going to start. So 6, and then I'm going to use synthetic. None of these worked. Positive 6 is the first one to work. So 1, 2, negative 45, negative 18. Let's bring down the 1, 6, 12, 72. Oh, this is, I'm sorry. I'm like, something's wrong. I multiplied. 2 plus 6 is 8. 8 times 6 is 48. Negative 45 plus 48 is 3. 3 times 6 is 18. 0. So 6 is a solution because I got a remainder of 0. I'm going to write my new polynomial, so 1x squared plus 8x plus 3. Now I definitely know that's not factorable. And I also know that the remaining zeros is a decimal because it is, and the other two, because I checked on Desmos, they're weird decimals. So I'm going to do quadratic formula. So a negative b plus or minus b squared minus 4 times a times c all over 2 times a. So I'm going to show you how to just get the decimal form straight from here. So negative 8 plus or minus the square root of 8 squared minus 4 times 3 is 52 over 2. I would really like it if you could simplify the radical. So 52 is 4 times 13. So that'd be negative 8 plus or minus 2 root 13, right? Because the 4 comes out all over 2. And then I can reduce. And in this case, I can reduce by 2. So negative 4 plus or minus the root of 13. So these should match what we get in Desmos, but you could stop there. So negative 4 plus the root of 13, negative 4 minus. Sorry, I was confirming that I didn't mess up. Sorry. You could also write these in decimal form. So negative 4 plus the square root of 13 is negative 0.39, and negative 4 minus the square root of 13 gives me negative 7.61. So you could write the radical form or the decimal form. I just want to know that you're able to solve it. The last one is a word problem, and so we're going to skip it. But for homework, I'd like you to skip numbers 9, 12, 13, 19, 25, and 26. Thank you.